Welcome to episode 13 of my calculus series. Today, we're diving into the chain rule. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. Overview. In this episode, we'll cover what the chain rule is, when and why we use it, the formula behind it, common types of composite functions, and tips for identifying the inner and outer functions. What is the chain rule? The chain rule allows us to find the derivative of a composite function, that means, a function inside another function. Mathematical formula. If y equals f of g of x, then the derivative of y with respect to x is f prime of g of x, multiplied by g prime of x. That's written as dy over dx equals f prime of g of x, times g prime of x. Why use the chain rule? Most real-world functions are compositions. Without the chain rule, they're nearly impossible to differentiate correctly. It's essential for mastering more complex derivatives. How to identify inner and outer functions? Take the function sine of 3x. Here, the outer function is sine of u. The inner function is u equals 3x. Chain rule structure. Step 1. Identify the outer and inner functions. Step 2. Differentiate the outer function, but leave the inner untouched. Step 3. Multiply by the derivative of the inner function. Common composite functions. Powers like, open parenthesis 5x squared plus 3 close parenthesis to the fourth. Trigonometric functions like, cosine of x squared plus 1. Exponentials like, e to the power of 3x squared. Logarithms like, natural log of 7x cubed minus x. Example 1. Differentiate, open parenthesis 3x plus 2 close parenthesis raised to the fifth power. We apply the chain rule. Derivative is 5 times 3x plus 2 raised to the fourth times 3. Final answer, 15 times 3x plus 2 raised to the fourth. Example 2. Differentiate, sine of 4x. Derivative of sine is cosine. Multiply by the inner derivative, which is 4. Final answer, 4 cosine 4x. Example 3. Differentiate, cosine of 7x squared. Derivative of cosine is negative sine. Multiply by the inner derivative, 14x. Final answer, negative 14x sine of 7x squared. Example 4. Differentiate, e raised to the 2x plus 1. Keep e to the power of 2x plus 1, then multiply by the derivative of the exponent, which is 2. Final answer, 2e to the 2x plus 1. Example 5. Differentiate, square root of 5x cubed minus 2x plus 1. Use the chain rule. Derivative is 1 over 2 times the square root of 5x cubed minus 2x plus 1, times the derivative of the inside, which is 15x squared minus 2. Final answer, 15x squared minus 2 over 2 square root of 5x cubed minus 2x plus 1. Example 6. Differentiate, tangent of 3x squared plus 1. The derivative of tangent is secant squared. Multiply by the inner derivative, 6x. Final answer, 6x secant squared of 3x squared plus 1. Example 7. Differentiate, natural log of sine x. Derivative of natural log is 1 over the argument, so, 1 over sine x, times the derivative of sine x, which is cosine x. Final answer, cotangent x. Example 8. Differentiate, secant of square root of x. Derivative is secant of square root x times tangent of square root x times 1 over 2 square root x. Final answer, secant square root x times tangent square root x divided by 2 square root x. Example 9. Differentiate, 2x squared plus 1 raised to the fourth times sine x. Use the product rule. First, differentiate the power. 4 times 2x squared plus 1 cubed, times 4x, times sine x. Then, leave the first term and differentiate sine x. That gives 2x squared plus 1 to the fourth, times cosine x. Final answer is the sum of both terms. Example 10. Differentiate, natural log of square root of 1 plus x to the fourth. Apply chain rule multiple times. 1 over square root of 1 plus x to the fourth, times 1 over 2 square root of 1 plus x to the fourth, times 4x cubed. Simplify. 4x cubed over 2 times 1 plus x to the fourth. Final answer. 2x cubed over 1 plus x to the fourth. Example 11. Differentiate. E raised to tangent of x squared. Derivative is e to tangent of x squared times secant squared of x squared times 2x. Example 12. Differentiate. Cosine cubed of 5x. Use the chain rule. 3 times cosine squared of 5x times negative sine of 5x times 5. Final answer. Negative 15 cosine squared of 5x, sine of 5x. Example 13. Differentiate. Arcsine of x squared. The derivative is 1 over square root of 1 minus x to the fourth times 2x. Final answer. 2x over square root of 1 minus x to the fourth. Example 14. Differentiate. Natural log of 3x squared plus 2x, all raised to the fifth power. Use the chain rule. 5 times the log expression raised to the fourth times the derivative of the inner log, which is 6x plus 2, divided by 3x squared plus 2x. Final answer. 5 times natural log of 3x squared plus 2x to the fourth times 6x plus 2 over 3x squared plus 2x. Final thoughts. The chain rule is one of the most powerful differentiation tools in calculus. To use it well, you have to carefully identify the function layers. Once you master it, you're better prepared for more advanced applications, even outside the classroom. Coming up in episode 14, we'll dive into implicit differentiation, learning how to find derivatives even when we can't solve explicitly for y. And that wraps up today's episode. If this helped you out, don't forget to like, follow, or subscribe for more lessons. Thanks for watching, and see you in the next one.